Hi guys, welcome to another video by Darklink Does Math. The content in this video is geared towards 6th grade math standards. These videos are public so that my students may access this information easily, as well as anyone else looking for math help. I hope you find this video helpful. If you do not, I hope you can find what you're looking for elsewhere. There's a lot of information out there. Be aware that I'm not perfect, so there may be the occasional mistake. I apologize in advance if this should happen. So today we're going over 11.1, nets, prisms, and pyramids. We've got, as you can see, quite a few vocabulary terms. Our first one is prism. Prism is a solid figure with two identical parallel bases. An example of a prism would be like a triangular prism. So let me do a quick sketch. It's not quite the best. All right, anyways, you'll notice that it's got, if you can tell, 3 rectangles and 2 triangles. And these 2 triangles are parallel to each other, and they're identical, meaning they're congruent, meaning they're equal in shape and size. So, because those 2 shapes are equal in shape and size, and they're parallel to each other, those are considered the bases. And that's actually why this is called a triangular prism, because the bases are triangles. Going to make a note of that. The bases are triangles. And we need to make sure that when talking about prisms, we don't necessarily assume base means bottom. Because as I've just told you, the bases on this particular solid are the triangles, not the rectangle. So we're going to make a note that base or the bases will not always be on the bottom. Why is that? Because you might turn the shape on its side. For example, let me show you an actual net of a prism. So here's a triangular prism. So if I sit this like that, yes, the base, the triangle, is on the bottom. But what if I turn it on its side? Okay, well right now, there's a rectangle that's on the bottom. But the rectangle is not the base, because the base doesn't necessarily mean what's on the bottom. The bases are the triangles. Why? Because they're parallel to each other. And we're going to discuss that in a little bit. So just remember, base does not mean bottom. Okay, next one. Pyramid. A pyramid is a solid with one base surrounded by triangle faces that meet at one vertex. You'll notice we keep using a lot of these vocab terms in there. So we're going to have to cover them. So a solid with one base surrounded by a triangle or by triangle faces that meet at one vertex. So here's an example of a pyramid. So I've got one base. Why doesn't it have 2 bases? Well, because there's not something that's parallel to it. On prisms, they have 2 bases, and they're always going to be opposite and parallel to each other. You'll notice this triangle on the bottom, it doesn't have one on the top. This one over here doesn't have one on the other side. This one right here doesn't have one going in the same direction on the other side. So one bottom, and it's surrounded by triangles that all come or meet at one vertex. Vertex means point, as we'll get to in a bit. So the difference between a prism, pyramid, prisms have 2 bases that are opposite and parallel to each other. Pyramids have 1. All right, next, a net. net happens to be the things that I keep showing you under the camera. It is a plane figure that can be folded to make a solid. So I'll pull out the last net I just had. So this net is a plane figure. That just means a flat 2D shape, and it'll usually have dotted lines or creases, and it can be folded to make a 3D solid. This solid being a pyramid because it's got one base. Another example of a net. It's a little too big for the camera. There we go. This net is made up of 6 squares. And if I fold it, it's going to make a solid or 3D solid. This one being a cube. So a net is simply a flat, plane figure that can be folded into a 3D solid. If it, like not any flat surface can be folded properly into a 3D solid. So nets can have different arrangements, but if it doesn't actually fold up properly, you can't consider it a proper net. Okay. Next vocab term, face. So I've used this at least once. Face simply means the surface of a prism or pyramid. So the surface. So let me pull back out the net of a cube again. These all are the surfaces, or make up the surface of the cube. So a face is this side, that's a face, that's a face, that's a face. They're all faces. So the useful thing about a net is it shows you all the faces at once. So I can see that there are 1, 2, 3, 4, 5, 6 faces. There are 6 surfaces. All right, next. Edge. Edge is the line formed by 2 faces meeting. The line formed by 2 faces meeting. So let me look at this prism right here. So here's a face, here's a face. There's the line that forms by them meeting. So essentially we're saying this is the edge right here. That's a line that's formed by this face and this face meeting. So here's an edge, there's an edge, there's an edge, everywhere there's an edge where 2 faces meet. So if I counted the edges, 1, 2, 3, 4, 5, 6, 7, 8, 9, a triangular prism has 9 edges, for example. Next one, base. I've used this a few times. Base is simply a surface of a prism or pyramid Now you'll notice that face and base have the same exact definition because really they kind of are the same thing. Why is there a difference? Base typically refers to, if you're talking about a pyramid, the bottom face. So if you're talking about a pyramid, the base is simply the face that's on the bottom, typically. Again, you can turn it on its side, so it might not be on the bottom. If you're talking about a prism, an object that has two identical faces that are on opposite sides parallel to each other. The bases are just a fancy name for the faces that are opposite of each other. So this rectangle face doesn't have a parallel rectangle face to it. So this rectangle is not going to be considered a base. This triangle face does have an opposite parallel triangle to it. So the triangles are considered bases. It's just it's a fancy name for a face. So faces and bases are simply surfaces. All right, next one, vertex. Vertex is a point formed where three or more faces meet. So let me pull out one of my nets again. So if I look at this unfolded, here's a surface or a face, here's a surface or face, here's another face. When they all meet, I get a point. This line, and this line all form to make that point. So that point is simply just called a vertex. That's all a vertex is. So how many vertices, which is plural, vertices, does a triangular pyramid have? 1, 2, 3, 4. 4 vertices, 4 points. All right, before we continue and do a couple examples, couple facts that we need to know. A prism, its name is based on the shape of its bases. And again, a base is also a face. The base is just a fancy name for one. So anyways, a prism its name is based solely on the shape of its base. So, a couple examples. This is a triangular prism. Why? Because the triangles are the bases. Why are the triangles the bases? Because there's two of them and they're parallel to each other. That's what makes them the bases. Another example. Here's a rectangular prism. It's made up of a bunch of rectangles. Why is it called a rectangular prism? Not because it has rectangles, but because the sides that are parallel to each other are rectangles. And actually, an interesting thing about rectangular prisms is all sides are pretty much opposite and parallel to each other. So no matter how you look at it, oh look, this side's parallel and equal to that side. Those are rectangles, so it's a rectangular prism. Oh, this side's equal to that side, or that side's equal to that side. They're all rectangles, so no matter how you look at this, it's going to be a rectangular prism. The only one that has a unique name is this. This prism, you would think, okay, well, the opposite sides or bases are squares. So would you call it a square prism? No, because, math has got to be difficult. We call this thing a cube. So it's got a special name, and it doesn't quite fit that, naming system. All right. A pyramid is also named by the shape of its base. So a triangular pyramid has a triangle base. A square pyramid has a square base, and so on. Okay, we're going to do a couple examples of naming and identifying a couple prisms and pyramids. So our first one, we've got this prism right here. Why is it a prism? Because I see two identical parallel shapes. In other words, it's going to have two bases. So this is a prism, not a pyramid. And the first one, what's it pointing to? It looks like it's pointing to a point where three lines meet. That is called a vertex. Next, what is this arrow pointing to? Looks like it's pointing to a line that's between this front face and the right face. that would be an edge. Next, this arrow is just pointing to, it looks like the front surface. What do you call a surface of a prism or pyramid? A face. Now, this one is pointing to the bottom face, but because there's one that's identical to the opposite one, or opposite side, this face has a fancy name, and we're going to call it a base. Now, I have noted that the base will not always be on the top and bottom. For rectangular prisms or cubes, we typically do always refer to the base as the bottom and the top. Okay, next, let's name this. Well, the two sides that are parallel and opposite of each other that are identical, they're rectangles, so we're going to call this a rectangular prism. We're not going to assume that those are squares. Rectangular prism. Don't call it a rectangle. It's not a rectangle. Rectangles are flat. It's a prism. All right, next, base. Again, for rectangular prisms and cubes, we are going to always refer to the top and bottom as bases. So I can pick one. Since this picture is pointing to the bottom, we're going to name the bottom. Now, how do you name this? You want to choose the letters going in clockwise or counterclockwise order. No zigzagging. So I'm just going to start with E and go around the shape. So E, F, G, H. So E, F, G, H. So notice I went clockwise. You could go counterclockwise. What can I not do? I can't go E, F, H, G. No zigzag. So E, F, G, H is going to be my base. I could do A, B, D, C. Okay, next. I want a face, but I don't want a base, meaning I want a surface that's, in this example, not the top and bottom. So I want the front, left, back, or the right side. Let's go with the one they're pointing at, which is the front face. So again, go clockwise or counterclockwise. I just like going clockwise. So we're going to start with C, then D, then G, and H. So rectangle CDGH is considered our face. That's not a base. All right, vertex. Vertex is a point. We're pointing in the example to vertex D. So that's the one we're going to go to. So that's my vertex, D. There are 8 possibilities, A, B, C, D, E, F, G, H. Okay, last one, edge. Again, edge is a line. So in the example, we're pointing to line DG. Remember from previous lesson, we write line DG like this, line DG. So we have named it, we've identified a base, we've identified a face that's not a base, we've identified a vertex and an edge. All right, one more example. First, is this a prism or pyramid? Let's look at the bases. Again, prisms have 2 bases, and they're going to be, shapes that are parallel to each other. Pyramids only have 1 base, meaning there is no other shape that's going to be parallel to another. So I see what looks like a rectangle and 4 triangles that surround it. Well, the front triangle, there is a triangle on the back, but they're slanted, essentially like that. So are those parallel? No. Parallel, is never going to touch. The right one and the left one, also not parallel. The bottom rectangle, does it have a top rectangle that's parallel to it? No. So there are no shapes that are parallel to another, so it's not a prism. It's a pyramid. Also, it's got a base that's surrounded by a whole bunch of triangles that meet at one point or vertex. So it's a pyramid. Now, what type of pyramid? Again, prisms and pyramids are named according to their base. What is our base? What's the shape that's surrounded by all the triangles? The rectangle. Again, I could turn it on its side. The base is still going to be a rectangle because it's the shape that's surrounded by all the triangles. So we're going to call this a rectangular pyramid. What are some other examples of pyramid? Well, earlier I pulled out this one. This is our triangular pyramid. Why? Because it's got a triangle that's surrounded by 3 other triangles. It comes to 1 point, so it's only got one base. Here's a square pyramid. It's got a square that is wrapped or surrounded by 4 other triangles that come to 1 point. So this would be a square pyramid because it's got a square base. That's the only examples I have at the moment. Okay, let's go through and see what the arrows are pointing to. So this is pointing to a point, where 4 lines are meeting, that we call a vertex. By the way, plural is vertices, like that. All right, next, this is pointing to a line. Lines are called edges. Next, this is pointing to a surface. So that's either going to be a face or a base. We're going to go with face because that rectangle is technically our base because it's being surrounded by the triangles. So this is our face. There are technically 5 faces, but the bottom face has a special name, base. Okay, now let's identify them. So again, the name was rectangular pyramid. Base, it's going to be the rectangle on the bottom. I know, all the examples, the bases are on the bottom, and I've told you that they're not always going to be. You'll see why later. All right, so anyways, the base, B, let's go clockwise. E, D, and C. So rectangle BEDC is our base. All right, next, a face that's not a base. So remember, all surfaces are faces, but I essentially want a face that's not on the bottom. So I want one of the triangles. Let's go with the triangle it's pointing to. Let's start at the top. A, D, C. And then next, vertex. I've got 5 options. Let's just go with the one they're pointing to. So pointing to vertex A. Last one, edge. There are 8 to choose from. We'll go with the one they're pointing to, which is line AD. So line AD. So these are just a couple examples of naming bases, faces, vertices, and edges, and naming the shapes. All right. We're going to move into just some characteristics of nets and prisms and pyramids. So we're going to go through cube, rectangular prism, triangular prism, square pyramid, and triangular pyramid. And we're going to list the shape of the faces, the number of faces you're going to have, number of vertices, number of edges, and what the shape of the base or bases are, and specifically how many of each there are. Okay, first one, a cube. Let's pull out a cube. A cube, if I unfold it and look at its net, what are the shape of the faces? They're squares. How many are there? 1, 2, 3, 4, 5. There are 6 squares. So a cube is going to have 6 square faces. Now, how many faces? I've kind of already answered that. Again, a cube has 6 surfaces, so 6 faces? Next, how many vertices? Vertices are points. So, I'm going to fold it back up into its solid form. I have 1, 2, 3, 4, and then on the bottom, 5, 6, 7, 8. So 8 points, so 8 vertices. Number of edges. 1, 2, 3, 4, 5, 6, 7, and 8, and then around the bottom, 9, 10, 11, 12. So there are 12 edges. And then, last, what are the shape of the bases? For rectangular prisms and cubes, not prism, sorry, it's been a long day. Rectangular prisms and cubes are bases we're going to consider to be the top and bottom. So what are those shapes? Well, it consists of 2 squares. And again, we are going to refer to the top and the bottom as the bases for those. Okay, next, rectangular prism. Here's a rectangular prism. I'm going to unfold it out into its net. For the purposes of this video, we are not going to assume that's a square. I honestly haven't measured it, so it's safest to say it's a rectangle. So what are the shape of the faces? In other words, what are the shape of all the surfaces? They're all rectangles. How many rectangles are there? There's 6. So rectangular prisms make up or are made up of 6 rectangles. Next, how many faces will a rectangular prism have? Well, if I unfold it and look at the net, how handy is that? I can see 1, 2, 3, 4, 5, 6. 6 faces. Next, how many vertices? Vertices are the points. It's going to be similar to the cube. 1, 2, 3, 4 on top, 5, 6, 7, 8 on the bottom. Total. Next, number of edges. Again, like the cube. So 1, 2, 3, 4, 5, 6, 7, 8, and then around the bottom, 9, 10, 11, 12. What are the shape of the bases? Again, prisms have 2 bases because there will be 2 shapes that are opposite, parallel, and identical to each other. So, top, bottom, both rectangles. So, on a rectangular prism, the shape of the bases will be the 2 rectangles on the top and bottom. Next, triangular prism. So, here's our triangular prism. Let's unfold it and look at its net. I have not measured those, so we're not going to assume they're squares. We're just going to go with rectangle, which is perfectly safe. So, what are the shape of the faces of a triangular prism? You're typically going to encounter 1, 2, 3 rectangles and 2 triangles. So 3 rectangles and 2 triangles. How many faces are there? Well, 3 plus 2 is 5, but we can count 1, 2, 3, 4, 5. So 5 total faces, 5 total surfaces. What's the number of vertices? Points. So 1, 2, 3, 4, it's been a long day. I can count, there are only 3 sides. So 1, 2, 3, 4, 5, 6 vertices. Good Lord. All right. Next, number of edges. These are the lines. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 edges. All right, shape of the bases. Okay, this example is kind of why I'm saying the bases aren't always on the bottom. So what again makes a base of a prism? They're the sides that are parallel to each other. These two triangles are parallel to each other. So that's why the triangles are the bases. Are these two triangles on the bottom? No, it's because the prism's on its side. So if I said, what's the base of this prism? You're not going to say the rectangle. You're going to say the two triangles. Two triangles are the bases. Why? Because they're parallel to each other. Those have to be the bases. If I said it like this, then yes, you can say, oh, the triangles are on the bottom and top. Those are my bases. It doesn't matter if I turn it on its side. The triangles are still going to be your bases. So, what are the shape of the bases? The two triangles, no matter where they are. They could be on the top, they could be on the bottom, they could be on the left, they could be on the right. You can diagonal it like that, and it'll be over here and over there. The triangles are your bases. Okay, last two. Pyramids. We've got square pyramid and triangular pyramid. So square pyramid is first. If I look at the net, I've got one rectangle. Sorry, not rectangle. Square pyramid. I actually did measure this one. So one square and 1, 2, 3, 4 triangles that wrap around it. One square and 4 triangles. So how many faces is that? Well, 4 plus 1 is 5, but if I'm not sure of myself, I could count 1, 2, 3, 4, 5 surfaces. So 5 faces. All right, how many vertices? Points. All right, let's not make the same mistake as before. So 1, 2, 3, 4, 5. 5 points, 5 vertices. Next, how many edges? 1, 2, 3, 4, 5, 6, 7, 8. What's the shape of the base or bases? Well, the square on the bottom does not have a square on the top that's parallel to it. The triangle on the right does not have a triangle on the right going in the same direction. This triangle does not have one going in the same direction. This triangle does not have one going in the same direction because, they're going to touch. They're tilted towards each other. Same and same. So there's only one base. It's the square on the bottom that's surrounded by the triangles. So we're just going to say the one square is your base. All right, last 3D object, triangular pyramid. Triangular pyramid consists of 4 triangles. What's the number of faces? Well, if there's only 4 triangles, there's only 4 faces, but if you're not really sure, count 1, 2, 3, 4. How many vertices? Points. We've got 1, 2, 3, 4. How many edges? 1, 2, 1, 2, 3, 4, 5, 6. And what's the shape of the base or bases? It's a pyramid because there are no parallel surfaces. So there's only one base. No matter how I turn it, it's going to be the one triangle. Okay, one more thing before I end this video. Triangular prisms. I mentioned it had 3 rectangles and 2 triangles. Now, triangles can come in different sizes or types. Like you've got equilateral triangles, isosceles triangles, scalene triangles, Equilateral means all three sides are the same. Now, I haven't actually measured this, but I suspect that these triangles are equilateral. They could potentially, all three sides could be the same. What does that mean? If all three sides of the triangles are the same, that means these rectangles technically would be classified as squares because they're going to wrap around that triangle. So if all three sides of the triangle are the same, then that means, well, at least these lengths are going to be the same. It kind of depends on this length here too. Now, what if it was an isosceles triangle? That means two of the sides are going to be equal, but the other is not. That means one of these rectangles or squares will have a shorter length. The other two that wrap around the triangle would be identical. So what am I saying? I'm saying that the type of triangle will decide the sizes of these rectangles or potentially squares. All right. I hope this has helped with identifying the differences between prisms and pyramids, as well as the characteristics of each. If it has not, I hope you can find what you're looking for elsewhere. Y'all have a great day.